What next is to talk about lab management. The safety of a research laboratory are highly rely on its management. There are 6 essence about the lab management. First, engineering control. The safety of the research lab can be partially controlled by engineering. So at the beginning, the design of the laboratory is very important. And then also, the facilities installed in the laboratory may determine the safety level of the laboratory. Just like the fume hood is related to ventilation, fire alarm system is related to the fire safety. Eye washer and emergency shower is related to personal safety. Of course, at the very beginning, we might have all facilities installed in the laboratory. However, to maintain their functions, we need to have good maintenance. Finally, there should be standard operating procedures for the lab members to follow. For example, every day when workers get into the laboratory, they have to be reminded to switch on the ventilation system. Besides the internal regulations, there are a lot of external checkpoints for the lab member to follow. We have to rely on the administrative control to keep track every issues for us. To fulfill this requirement, the laboratory has to set up the inspection system to make sure that all the workers will follow the external checkpoints. What next is to receive the training and education. This type of training and education is different from the general safety training. The laboratory has to provide you specific training about your research topics. And then you need to have personal protection. And also you need to know how to carry out damage control if in case of accidents. And finally, you need to know how to respond to the emergency situations. Lab management is the most important part in lab safety. First, keep clear the exit, because it is very important for persons to evacuate quickly from the laboratory in case of emergency. In addition, don't handle self-igniting chemicals or inflammable solvents nearby the exit. Solvent and chemicals should be stored in cabinet when not used. Reminded that don't store chemicals in the fume hood. In the laboratory, all kinds of safety equipment has to be equipped, just like fire sand, fire blanket, fire extinguisher, and also evacuation plan and map, first aid kits, chemical absorbers for spills, and updated emergency phone list should be available and accessible. Safety data sheets for chemicals has to be collected and stored in the laboratory, and supposedly to be accessible when necessary. In addition, keep clear the location around the emergency shower, ice washer, electrical panels, breaker panels, water shut-off valves. They have to be accessible in case of emergency. Some regular actions has to be carried out. First, preparation planning for emergency drills and practice. Second, the lab inspections. Third, risk assessment. Mandatory buddy system has to be enforced. Before you start your lab works, make sure that you recognize all hazards and also understand the standard operating procedures for how to handle these kinds of hazardous materials and instruments. The second indeed is to understand the decontamination process if in case accident occur. Later on in next section, we are going to discuss about some decontamination process. And also you need to understand the emergency escape routes and plans if in case of accidents. In particular for fire accidents, it is really important to know how to use fire extinguisher appropriately. If in case of chemical splash, you need to know how to use the eye washer and also the emergency shower. If in case of cuts, you need to know how to use the first aid kit to stop bleeding. And in case of the heart attack, you may have to understand how to use the AED. Please remember that you should keep your lab mate's line or contact phone number in your mobile phone, and also your professor's number, university security numbers. In addition, reminder that if in case you need to call police, please dial 110. And in case of fire accidents or maybe you need ambulance, please call 119. Never hesitate to dial these two numbers. Either one will contact you to the rescue team. Just dial the number if in case you need. If you need to use chemicals intensively, you are supposed to receive another 3 hours of education on hazard communications. Following are the general basic guidelines for handling chemicals in a building. You should carefully check the safety data sheets for safety precautions of those transported chemicals. If you are unable to access the safety data sheet of your chemicals in English version, you can go to the American Chemical Society website to collect the safety data sheets information for your chemicals. Here is the ACS website address for your reference. For all chemical bottles, there should be GHS pictograms and ACS chemical numbers on the bottles. Basically, there are 9 different types of labels for chemicals classifications, including health hazard, gas cylinder, flame over circle, flame, corrosion, environment, exclamation mark, exploding bomb, skull and crossbones. For gas cylinder, usually the content will be compressed gases or liquefied gases or dissolved gases that cause high pressure inside the cylinder. The sign flame over circle indicates oxidized gases, liquids, and solids. As we can see, the circle means oxygen, which indicates that it is a strong oxidizer. The sign of flame means flammable materials, including gases, liquids, and solids, or may be self-reactives or pyrophorics. The sign of corrosion means the chemicals may attack your skin and cause serious eye damage. The sign of environmental toxicity means they will kill the animals or life form in water and also on land. Exclamation mark, which indicates that the chemicals may be irritant, thermosensitizer, or acute toxicity, or harmful. Exploding bomb, which indicates that the chemicals may be explosive, self-reactive, or organic peroxide. The sign with skull and crossbone indicated the acute toxicity or may be poisonous. Chemicals that are not used should be kept and locked inside the chemical cabinets, inside the second container with label. The inventory of the chemicals should be updated periodically. All chemical bottles has to be labeled. Please don't store chemicals on the floor. It will be really dangerous if they are knocked over, in particular for hazardous chemicals that may cause serious contamination. All the bottle has to be labeled. In this picture, you can see that there are 2 buckets of chemicals without chemical labeling. Flame is a primary control device for protecting researchers from working with flammable or toxic chemicals. Continuous airflow will bring all contaminants out of the laboratory. However, you should receive training in order to use the flame hood appropriately. When you need to use the flame hood, following are the points that you have to pay attention to. First, ensure that the hood can be switched on. Check the airflow to make sure that the fume hood is functioning appropriately. Make sure that the sash can be pulled down and pushed up smoothly. So if in case of emergency, the sash can be pulled down quickly to protect the operator. Since the area inside the hood is highly contaminated, so never allow your head to getting inside the hood. For vertical rising sashes, keep the sash below your face. For the horizontal sliding sashes, keep the sashes positioned in front of you so that your body is protected by the sash, and work around the side of the sash. Keep all materials inside the hood at least 6 inches away from the sash opening. Otherwise, the air turbulence outside the hood may bring the contaminant out of the hood. When not working in the hood or after finishing the setup for the experiment, close the sash. Fume hood is a place of high risk. Don't keep unused chemicals inside the fume hood. So in case of accidents, we can reduce the probability of having the second incident inside the hood. The structure of fume hood for coating is quite similar to the fume hood for chemical synthesis. The purpose of the fume hood is to protect the user away from inhaling hazards and for removal of flammable solvents and aerosols. Due to the intensive use of organic solvents inside the hood, electricity and static electricity are also sources of ignition. So make sure that there's no source of ignitions inside the hood. Any electrical extension cord or electro appliances are forbidden inside the hood. During the operations of the fume hood, make sure that ventilation is functioning. You have to have eyes protections, head shields, work coats, and also safety masks. So in summary, here is a checklist for the fume hood safety. Please read this checklist carefully, and every time when you use the fume hood, please read this checklist once again to make sure that your fume hood can be operated properly. If you don't have any airflow meter at hand to monitor the operation of the fume hood, maybe you can use a piece of skim swab to illustrate the direction of the airflow. That's so easy. Just use a piece of Scotch tape and tape the skim swab on the sash. The wave of the skim swab will show you the direction of the airflow. Finally, remember, don't put any unused bottle or chemicals inside the hood. The bottle will block up the airflow, creating turbulence inside the hood. The turbulence will flush the contaminant out of the hood. Multidisciplinary researches are very common nowadays. The gap between biological and chemical researches are smaller and smaller. However, biological research involving microorganisms can be very dangerous, causing biohazards that may hurt your health. Biohazards spread widely in water sources, including aerosols, and are threatening human health at even a small dose. This can include medical waste or samples of microorganisms, virus, or toxins that can affect human health. Usually, infections will be the most serious one because the invasions and multiplications of the microorganisms in your body may even kill you. Sometimes this material will lead to the allergy. An allergy is a reaction by your immune system against the external substance, such as pollen, that cause reactions. Sometimes, if your immune system overreacts, it may hurt your health. The last one is biotoxin. Biotoxins is a poisonous substance produced by the living organism. Toxin is kinds of the toxic chemicals that can interrupt the operations of your body. Indeed, biohazards are common in lab accidents. Survey by Scientific American in 2011 revealed that nearly 400 accidents with dangerous pathogens and biotoxins occurred in the United States, spanning a period of 7 years, which means that almost 60 cases per year. Please remember that once the microorganisms get into your body and infect you, it is no guarantee that you can recover from the disease. If you need to handle biohazardous materials, you need to first finish an 8 hours of training and being licensed. You need to handle the biohazardous materials inside a biosafety cabinet. The design of this cabinet is different from a normal chemical film hood. There are two pieces of HEPA filter. One is for filtering the inlet air, while the second one is for filtering the outlet air before they are released to the air. This kind of cabinet is only suitable for biohazardous materials handling, but not suitable for chemical handling, which means that this cabinet cannot be mixed use. If you need to transport chemicals, you have to pay attention to the following precautions. First, you should use safety carrier for chemical transport. In addition, you should not take the passenger elevators for chemical transport in order to avoid any possibility of causing public danger. Furthermore, if you need to transport any fragile sample tube, such as NMR tube, you should use protective carriers. The last point is, don't ride in the same elevator with the filled liquid nitrogen tanks or any kinds of liquid gases, dry ice, or liquid chemicals. Warning signs has to be put onto the tanks in order to give warnings for the other people. Next topic to discuss is about chemical spills. Chemical spills commonly occur in lab accidents. How dangerous it can be? There's no simple answer to that question because the hazard level depends on a variety of factors. But indeed, chemical spills can be highly hazardous. The severity is not only determined by the amounts of spills, but also the nature of the chemicals, and also the environment. Even small amounts of spills, less than 100 milliliters, can be fatal sometimes. Please check the SDS about the chemical spill cleanup procedure before using the chemicals. And also the corresponding spill kits has to be prepared in advance. So if in case of spills, you can treat the spill quickly. After chemical spills occur, you should alert others in the laboratory and cordon off the affected area. Make the judgment to see if you are able to handle these kinds of the chemical spills. If you have any questions or hesitate to do that, please call your EHS center. Following are two fatal examples on chemical spills. The first case occurred in Netherlands. A 25-year-old chemist spilled a few milliliters of fluid containing methylphenosulfate on his lab coat and pulled over. He immediately took off the coat and cleaned his pullover with water. However, perhaps he had already inhaled some of the vapor of methylphenosulfate. He died the next day despite intensive treatment due to pneumonia edema. The final investigation suggested that his death was due to protein denaturation. The second case happened in Hong Kong. Bottles of acrylyl chloride and methacrylyl chloride were overturned. The student in the laboratory simply evacuated and closed the door without putting any warning signs on the door. Later on, another student got into the laboratory without receiving any warning. The student stayed briefly in the lab to rinse his irritated eyes and arrived at the hospital 1 hour later. His situation became worse and worse after a few hours, and he died 23 hours later after admission due to pneumonia oedemia. If in case of minor chemical spills, you should follow the following procedures. First, you should alert others in the laboratory or in the building. Cordon off the affected area, and you should make sure that you are safe. And then you put the goggles and chemically appropriate gloves on with long closed-toe shoes and long-sleeve lab coats before approaching the spills. Prevent the hazardous materials from reaching the drains using a boom, sock, or other materials. A picture is shown below. Okay, you can surround the spills by the booms or socks, and then use the absorbent pads spill kits to absorb the chemicals, and take that away and put it into the plastic bag. After finishing all the procedure, place all the waste material in a plastic bag. Once the spill has been fully cleaned, place the waste bag in the film hood temporarily, and label the bag as hazardous waste and submit it as a chemical waste disposal. And then remove all personal protective equipment and wash your hands completely with soap and water. Please don't forget to report to the EH Center about the spills and replenish your spill kit supplies. Following is a video about minor chemical spills treatment produced by Iowa State University. You can access this video online through YouTube.
You place a bottle of chemical waste on the counter and step into the next room. Then you hear a loud crash. You return to find your bottle broken on the floor. Since you have user knowledge of the spilled material, you know that there is no significant hazards present, and you have the appropriate training to clean up the spilled material. If you didn't have user knowledge of the spilled materials, you would want to consult a safety data sheet for proper spill cleanup procedures. Please contact EH&S at 294-5359 if you don't feel comfortable addressing the spill on your own. First, retrieve a spill kit. Place an absorbent barrier around the spilled material. Use tongs to remove any broken glass from the liquid. If dry, remove the green waste tag from the broken bottle to keep for later use. Place any broken glass into the laboratory glass collection container. Slowly work from the outside in, placing floor dry onto the spilled material. Wait a few minutes, allowing the spilled chemicals to absorb. Slowly mix the floor dry and sweep up the material. Put the used floor dry into a plastic bag. Attach the green label removed from the broken bottle to the bag of cleanup material and label as spill cleanup material. Once finished, contact your lab supervisor and environmental health and safety as needed. Restock the spill kit for future uses.
If any hazardous material has spilled on you, please follow the following procedure. First, remove the affected clothing immediately and flush the area with water. The first step is a very important step. If you don't remove the affected clothing immediately and flush the area, the affected area will be expanded. Ask your lab mates to get emergency rinsing solution to flush the area for decontamination treatment within 1 minute. This is a very important step to stop the chemicals penetrate into your body. Keep flushing the area with water for at least 15 minutes more, and go hospital for emergency treatment. The emergency rinsing solutions can be Diphoterin is an emergency rinsing solution for spreads of chemicals, acids, or bases. It is a very useful neutralizing agent that can cope with acid and base effectively. However, emergency treatment should be carried out within 1 minute for decontaminations. Flush with water for at least 15 minutes more and sent to the hospital. Here is some pictures of the diphoterin. Diphoterin can be directly applied to your eyes. It prevents the aggressions from penetration. When hydrofluoric acid has spilled on you, you should be treated with hexafluorine. Hexafluorine is the effective neutralizing agent that can remove the hurts from HF. However, don't forget one thing indeed is diphoterin and hexafluorine cannot be used at the same time. Tetramethylammonium hydroxide is a photoresist developer or agent that has been used commonly in semiconductor industry or photoelectric industries. Due to its strong alkaline properties, these chemicals may cause chemical burns. In addition, absorption of tetramethylammonium hydroxide through skins may also result in respiratory failure or sudden death. During the last few decades, there are totally 13 cases of exposure and 3 patients who died after being exposed to 25% of tetramethylammonium hydroxide. Severe effects were observed even after exposure to 2.38% of tetramethylammonium hydroxide, indicated that even diluted tetramethylammonium hydroxide solution can be dangerous. However, the toxicity of tetramethylammonium hydroxide can be neutralized by diphoterin. Therefore, if in case of tetramethylammonium hydroxide splash, one should use diphoterin for decontamination as soon as possible. Hydrofluoric acid is a serious systematic poison. Even a small-scale spill of hydrofluoric acid could kill a person. In 1995, a technician in Australia died from multi-organ failure after small-scale spill of hydrofluoric acid. In this incident, the lab had no emergency shower, nor any calcium gluconate gel antidote available in the laboratory. Since hydrofluoric acid is highly corrosive and can have delayed health effects which are due to the deep tissues penetrations by the fluoride ion, one cannot predict its effects based on the surface area of the burn. The right photos shows the hydrofluoric acid damage on the victim's fingers. Why contact of hydrogen fluoride is fatal? Hydrogen fluoride is a highly toxic material, causing severe electrolytic imbalance that results in heart fibrillation, leading to cardiorespiratory arrest and multi-organ failure. In order to neutralize the toxicity of hydrogen fluoride, calcium treatment is critical. It is simply because calcium can bind with fluoride and neutralize its toxicity. However, the neutralization has to be carried out before the fluoride ion getting into the tissue. Hexafluorine is a known first-aid rinsing solution that can help to neutralize the toxicity of hydrogen fluoride. Hexafluorine can be used to treat the antibody, including the eyes, oral cavity, and ear canals. If anything getting into your eyes, you have to first flush them out completely. The first 10 to 15 seconds is the most critical time period for you to remove the contaminations. Please use the ice washer to wash it, and also use the neutralizers to decontaminate the chemicals in your eyes. After that, keep flushing your eyes with eye washer for at least 30 minutes. If possible, take off your contact lens and flush your eyes thoroughly. At the same time, call an ambulance to send the patients to hospital. Irregular heartbeat can be fatal. A heart with irregular heartbeat may not be able to send blood out to the body, causing brain damage due to the lack of oxygen. AED, Automated External Defibrillator, is a portable electronic device that automatically diagnoses the heart arrhythmia. An application of electricity which stops the arrhythmia, allowing the heart to re-establish an effective rhythm. Following is a video published by British Heart Foundation and also Memorial Hermann. In the video, the emergency number they use indeed is a British emergency number, 999. In Taiwan, the emergency number should be 119.
This is a defibrillator. It can save someone's life, but only if you use it. A defibrillator is an easy-to-use device. You don't need any training to use it, because it will tell you exactly what to do.
Shock advised.
Its job is to shock someone's heart back into a normal rhythm during cardiac arrest. However, it will only instruct you to deliver a shock if this is needed. If you find someone unconscious, unresponsive and not breathing, or not breathing normally, they're in cardiac arrest. It's important to act immediately because their heart is no longer pumping blood to their brain and around the body. The first thing to do is call 999 and start CPR. The emergency operator will talk you through what to do and tell you where the nearest defibrillator can be found. If there's someone else around, ask them to go and get it. Defibrillators are normally located in workplaces and public spaces like airports, shopping centres, community centres and train stations. They may be labelled PAD, Public Access Defibrillator, or AED, Automated External Defibrillator, and anyone can use them in an emergency. The defibrillator will assess their heart rhythm and will only tell you to shock them if they need it.
Shock advised.
So you can't do any harm by using one. If a shock is needed, this will try and reset the electrical system in their heart to get it beating normally again. When used with CPR, defibrillators give the best chance of survival. So, when you witness someone in cardiac arrest, take action. Start CPR and find a defibrillator as soon as possible. For more information on defibrillators, visit bhf.org.uk/defibs. BHF. Beat heartbreak from cardiac arrest. Beat heartbreak forever.
Cardiac arrest essentially, in most cases, happens when the heart goes into an abnormal fast rhythm coming from the lower chamber that's chaotic. And while it's chaotic, it does not result in a coordinated contraction. So the body is not getting any blood flow. What a defibrillator does, now this rhythm is called a fibrillation. The heart is fibrillating, it's beating in a very uncoordinated, very chaotic manner. So the defibrillator, what it does is it terminates that rhythm. Now the ones that you see in the public places, we have a lot of defibrillators that I've seen in malls, parks, and I believe they're now in some schools as well. What it does is a defibrillator will guide you through the steps that are needed to terminate that rhythm. The faster that rhythm is terminated, the earlier the heart restores normal rhythm and a coordinated beat, so that blood flow is now going to the vital organs, including the brain, the kidney, and the heart itself. What the defibrillators now do is they facilitate the procedure by announcing what needs to be done. So a bystander, if he sees someone undergoing cardiac arrest, someone collapsing, all he or she needs to do is take the defibrillator from the wall or wherever it's located, place it on the chest, and it'll announce the next step to be done. And so what it does is it facilitates early recovery of heart rhythm, of normal heart rhythm, which is so essential to life. And
Following is the YouTube of CPR and AED demonstration.
CPR 其实不难 ，AD 操作就更简单了。当我们看到有人突然倒下，首先呢，我们确认现场是否安全。如现场安全，一般民众如果你不愿意做人工呼吸，我们可以选择简单的胸压加上 AD 的操作。口诀是叫 CD。先生，怎么了？没有怀孕，没有呼吸。所以，小姐麻烦拨119叫救护车，同时拿 AED。
解开病患胸部的衣物。当露出病患胸部时，开启灰色塑胶盒，并撕下白色自粘电极线，仔细查看白色自粘电极线上的粗线，从灰色盒子内撕下一片白色电极线，请依显示放置电。
好，离开。
分析心脏节律，远离病患，分析心脏节律。建议远离病患，立即予实施。请确认已拨打电话通知紧急医疗救护服务，可以碰触病患，开始进行 CPR。如需 CPR 语音协助，请按下闪烁的蓝色按钮。将手掌根部置于乳头之间的胸部正中央，将您的另一只手置于脐上，用力将胸部向下压5公分，配合心跳。
全民 CPR 加 AED， 掌握抢救生命黄金5分钟。
If you are interested in knowing the location of AED on campus, please check the following maps or go to the website for that. On the map, you can see a red sign with a heart on that. These are the locations of the AED. Students carry out research every day and will create a lot of laboratory waste due to their research activities. What should they do on those lab wastes? Are they allowed to simply throw them to the garbage can? These questions have confused our students quite a lot. In these sections, let us discuss the lab waste problem. Waste in university can be classified into two categories: household garbage and research waste. Laboratory waste related to research has to be picked up by special licensed company. They can be classified into general business waste and toxic business waste. Toxic waste, including radioactive waste, infectious waste, liquid chemical waste, solid waste, and outdated chemicals. They have to be removed through our Environmental Health and Safety Center. On those wastes, the corresponding label has to be attached. Chemical waste is the major hazardous waste on campus. Although we may think that they are useless, this doesn't mean that they are completely deactivated. Many accidents have occurred due to careless mistakes on chemical waste handling. First of all, never assume a chemical waste is safe for disposal in a regular trash or via a sink or drain. They have to be collected in the waste container and has to be handled by a licensed company. Collection and management chemical waste as hazardous waste is the safest and the most responsible way. A chemical waste must be classified and managed as a hazardous waste if it exhibits any of the 4 characters described below, or is specifically listed in the regulations. Let us see the characteristics of the waste. First, if they are ignitable. Second, if they are corrosive. Third, if they are reactive. Fourth, if they are toxic. Chemical waste should be classified and collected separately. The classification of the waste are shown in the following scheme. Basically, there are 3 major categories. Type A is for organic solution waste. Type B is for inorganic solution waste. Type C is for solid waste and sludge. There are 3 subcategories for organic solution waste. The first, indeed, is oil. The second is halogenated solvent. The third is non-halogenated solvents. They should be collected separately. For inorganic solution waste, there are 7 types: heavy metals, cyanides, mercury, fluorides, acids, bases, and +6 chromium. They should not be mixed together. For solid waste, we can classify them into combustible, organic, or inorganic. Never dump expired chemicals and useless chemicals in the waste containers. It is simply because they are still chemically active. If you mix them together, they may react. Before we start to use a waste container to collect chemical waste, we should first put the classification label on the container. In addition, we need to prepare a secondary container for spill prevention. The size of the secondary container should be large enough to cope with the chemical waste spill. In addition, do not fill up the waste container completely. Otherwise, chemical spill might occur during transportation. Ship out the chemical waste regularly. Please don't pile them up in your laboratory. For biohazardous waste, several precautions has to be paid attention to. First, the infectious solid waste should be treated and disinfected before picking up by the waste treatment company. Any swabs also has to be treated and disinfected and kept in metal container in order to avoid causing any physical hazards. Always must be labeled with the generator's name, address, and telephone number. Finally, we should come up to a summary. First, research lab may not be safe. Second, creating and understanding safety culture is important. And safety education has to be broad-based. Only a small group of professional people understanding safety issues is not enough to secure safety. About the safety guidelines, several points you have to keep in mind. Don't work alone. Don't scale up. Check all the precautions at any time and protect yourself. In case you need, please call for help. Protect yourself and you can go further. Thank you for your attention.